Hey, hi guys. So, attendance. We have looked at the type of attendance as in sequence to sequence, vector to sequence, and sequence to vector kind of stuff, and different applications of this attendance. The fourth kind is where you have combination of both, where you have sequence and um, where it takes certain steps takes only input and certain steps is so it's kind of many to many where need not necessarily be one to one, like sequence to sequence with equal number of inputs and outputs. It could be different varying inputs and outputs, which could be used for translation kind of use cases, right? There could be four English words and there could be two Spanish words, which represents the meaning of it. So those kind of things, right? So we go there, we'll try to understand more. But the open question that I have that we need to understand is so given a sentence, let's say, with certain words, if you want to translate it to a certain sentence in a different language, you can't. So there are two ways, right? You can actually translate it word by word, like what is your name, then it will translate what and is your name. So it will give two, three, four words, equivalent words in Spanish. You could put them side by side. That doesn't mean they give you a right meaning in Spanish, correct? So um, maybe what is your name in Spanish has I don't know, maybe two words or so. In a different language, it could also have more words. So you can't say it has equal or less or greater words, right? So, um, how does the AI model, if you take it through RNN, what is happening? It has two. I mean, RNN in the sense, let's say, because base RNN will not be used by anybody. That is understood when we're discussing, because it has a problem with respect to exploding or diminishing gradients kind of stuff. So the capability of using the historic data or context data within the flow is being impacted. So the way to go is LSTMs, right? So long short-term memories. GRU is there, but it's they are more optimization of LSTM. Both are same. GRU and LSTM are same, but except the difference is GRU is more optimization to reduce the computation need of LSTM kind of stuff. So, oh, yeah, all combined together, you can actually look at it as LSTM cells. Um, so, so when I use RNN, I mean LSTM is the way to go. Is what we'll use. Um, but what we are doing, we are in the flow at a given point of time in a LSTM, we are calculating even if there are 100 words in sequence, like we are converting it into, from the output perspective, we are converting it into one, it's 100 outputs for each. LSTM cell will give an output, and also it will pass on to the next one. Um, and also you get one output at the end. Um, so the question is, how does it map these words, English words? Let's say I'm for example, I'm taking the task of translation, but how does it map English words to the relevant other language? How does it learn? How does it remember saying, okay, this is the sentence, what is your name? Or like, how was your day? Something like that. If there's a question, how does it remember and give certain answer, right? So we need to see whether it is relying, because the end memory wise, how does it store? Does it store the intermediate level details during training, or how does it store the last number basing on which it gives the output, or what, because when you process the whole thing and give it to the next level, you might not be giving the whole intermediate outputs, right? You'll be giving the final output. Let's say you have 5 LSTM cells. At the end, whatever is coming output, you can give the intermediate also. But let's say if you're giving the end output to it, then it will get one number. Even though there are 100 words, you get one number representing those 100 words. What one number, how does it tell, saying that, that one number represents these 100 words, right? So that's one thing. Second thing is, um, basing on that one number, how does it know that what is the translated sentence? Does it, so we need to get details saying, does it remember for each possible combination of sentence? No, it's not. So then how does it work is the question. To understand this better, first we need to understand how the embedding process is being done. That will look at it. Then we'll look at the problem in hand is sequence to sequence, right? How does the sequence to sequence generation happens with the different inputs? So these are the two things we'll quickly see. We'll start off with word embedding. Okay. Well, for these videos, I've already seen StatQuest is doing a good job. So we'll go with StatQuest to understand how the word embedding is working. So StatQuest word embedding.
ఈరోజు దానికి వీడియోస్ అన్ని యాడ్ చేశాను. निर्विघ्नं कुरु मे देवा सर्वकार्येषु सर्वदा। ॐ भूर्भुवस्सुः तत्सवितुर्वरेण्यं भर्गो देवस्य धीमहि धियो यो नः प्रचोदयात्। ॐ नमो नमः।
So, um, embedding is something that we have seen. Long one. Word embedding, he has explained. Word embedding, I've been thinking word embedding works like you take a dictionary of words and then you embed each of the word with certain number, and those will be used as the representation of the particular word. That's I was thinking, but looks like the embedding process that he has explained is specific to each text itself. It's not, but if the embedding is specific to each text, okay, even during training, they'll take the current text and apply the same embedding methodology, but the number representation of that particular word could be multiple, will vary from training to that of the examples that we pick up, because the sentence and context could be different. So it looks like it's complex. It's not just simple saying all the words are given some numbers, and those numbers are fixed, and the model will, basing on the numbers, understand the sentence, and it will try to predict the output. This is not that simple. So the embedding words could be different basing on context for a given word. One observation. Second, we are not only talking about one embedding for one word, there could be multiple embeddings for a single word, and all of them will be considered at the same time, and then we process the output. This is where it is making it complex, and that is where, by making it complex, is where it is being able to deal with more scenarios. Okay, sounds good. So I think the embedding needs more deeper dive. StatQuest has given a high level overview, but we need to get deeper into understanding how the embedding works, what are the different types of embeddings and all that stuff, and how they work and stuff. Because embedding is definitely undeniably the backbone of the whole processing, and if embedding is not clear, and we are not able to embed the data that is coming in for our model properly, we will not be able to either train or predict proper outputs as required. Kind of. So we'll spend more time on embedding to understand it better. That's it for today. We'll meet again tomorrow.